Alright, so in problem 15, we got to use the data from 13. It's already in our calculator. We got to estimate a 95% confidence interval, interpret it, and then we got to does it suggest that there's a difference? So again, we have the data in our calculator. Now the problem is we got an outlier, right? So we got to note that. So again, our parameter here is the average runs in the American League, and then U of N is the average runs in the National League. Okay. The assumptions and conditions. This are representative samples. Okay. Our N value for both of these are 14 and 16. So 14 and 16 are both less than 10% of all seasons. Okay. The samples are independent. And then we already looked at the distributions, right? So the problem is, number one, there's an outlier, and number two, the National League is skewed, right? So the National League is skewed, and it has an outlier. So when we put down the American League look like that. That's roughly unimodal and symmetric. However, the National League, okay, not only is it skewed, but it has an outlier. Now, this is roughly unimodal and symmetric. Now, does it meet the conditions? No, it doesn't. Okay. So what we have to do is proceed with caution. Alright. This is going to be a 2-samp T-int. And then we got to get all of our key players, right? So stat, calc, one of our stats. So that's all for the National League. So, I'm sorry, the American League. So X bar for the American League is 9.81. Standard deviation for the American League is 0.805, and N for the National League is 14. And then we'll do the same thing with the National League is 9.58. Standard deviation for the National League is 1.55, and number, this should be American, this is national. Okay, that should be American and that should be national, is 16. Okay, now you might be saying, well, Mr. O'Neill, why don't we just throw that outlier out? Well, you have no, you can't just take an outlier and throw it out. You have to have a reason, and right now we don't have a good reason to just eliminate one of those. Could have been that they had a really good team. Okay, they just had a bunch of guys who could hit the ball, or could have been where the game was played. Okay. So our interval, we're going to do x bar sub 1 minus x bar sub 2 plus or minus t. We got to figure out what that degree of freedom is, times the square root of 0.805 squared over 14 plus 1.55 squared over 16. And we're going to just go to the calculator, and we're going to do stat calc or stat test. Then we got to go to 2-sample T-int. That's there, right there. We're going to do L1, L2 95%, calculate. So that'll give us our degrees of freedom, 23.15. And our interval actually calculated out to negative 0.69 to 1.14. I just like to get that. So we're doing a 95% confidence interval, so I'm going to do inverse t, 0.975, and then 23.15. That's going to be our t value. So 2.07. So I'm just going to make t equals 2.07, and then the conclusion is we are 95% confident the average runs scored in the American League is between 0.69 less than to 1.14 more than the average runs scored in the National League. Okay. So question C says, is there evidence of a difference? Well, no, because 0 is in the interval. If this was positive 0.69 to 1.14, then we could say, oh yeah, in the American League, definitely they score more runs. But since 0 is in that interval, we cannot say that. So that would be the answer to C. Okay, now in D, they want us to eliminate Coors Field. So we got to go into L2 and get rid of that 14. So just delete it. All right. So everything else is going to remain the same. The 9.81 is going to stay the same. It's the National League that's going to change. So we got to get new statistics for the National League. We're not going to check the conditions again. We obviously, it would eliminate the outlier. It wouldn't eliminate the skewness. So there's still going to be an issue with the distribution. So we're going to do 1 bar stats of L2. And our new runs, X bar now for the National League is 9.29. Standard deviation for the National League is 1.04. A lot less variation, right? Went from 1.55 to 1.04, and now n is 15. So our confidence interval is going to be 9.81, which is the American League, minus the new mean of 9.29, plus or minus t, and we've got to do the square root of the standard deviation of the American League squared over 14, plus the new standard deviation of the National League squared over 15. Okay, so now we just go to the calculator and we're going to go to 2 samtn, and we're going to calculate that. And our new interval, so negative 0.19, 1.23. So we're 95% confident that the American League will score between 9.19 less than to 1.23 more than. So again, there's still no evidence that the American League will score more.